Good afternoon. Can everybody hear me okay? Thank you very much for joining today. Thank you for coming to the DC Summit and taking time out of your schedule and spending Wednesday afternoon to talk about SageMaker Inference. I'm Aaron Sinstack, I'm a machine learning solutions architect at AWS. I've been a solutions architect at AWS supporting public sector customers for about 2.5 years. Prior to coming to AWS, I was an aerospace engineer and spent 12 years both in robotic space exploration and avionics for manned and unmanned systems. But today we're going to talk about SageMaker, and we're going to talk about SageMaker Inference, so one piece of the machine learning lifecycle. In the last 12 months, we've doubled the number of options that we have for SageMaker Inference, and we'll talk about all those options. We'll compare and contrast what style is right for you. And we're going to come back to it today, really 3 areas, right? Cost, use case, and constraints for each different inference style within SageMaker. How would you choose one over the other? Before we get into the deep dive of asynchronous inference versus synchronous inference, we're going to ground ourselves in terminology and introduce what is SageMaker. There could be a number of you in the room here that this is the first time you're familiar with the service. We'll also talk about what is inference. This might be a new word to some, and where does it fit in the machine learning lifecycle. We're then going to go very deep into the different architectures for inference options. We'll provide some best practices at the end of the presentation, really cost optimization. How do we optimize our deployed machine learning models that are in production? And then I'll provide some resources on how to get started. We probably will have about 10 minutes at the end for questions, so I'll stick around for Q&A. If there's any questions that I can't answer, or we want to go even deeper, I'll be hanging out in the hallway afterwards so we can talk one-on-one there as well. Let's dive in and get started. Okay, so what is Amazon SageMaker? SageMaker is a machine learning platform for data scientists, for machine learning engineers, and for business analysts. It's a machine learning platform that spans the entire life cycle of machine learning. This is from data labeling to deploying models in production. And it's a managed service. So what does that mean when we say a managed service? Like, many services are managed. SageMaker is managed. What does that mean? A managed service is one that's going to provision infrastructure on your behalf. Right? So now instead of your data science team deploying EC2 instances, we can configure our workloads and let SageMaker manage that. We get to allow our machine learning engineers and data scientists to focus on data science and machine learning and not getting 2 EC2 instances to talk together and not on security groups for our EC2 instances. We let SageMaker manage that under the hood. We're going to come back to that, and we'll show how in the inference phase of machine learning, how that works and how the managed portion of SageMaker is happening under the hood. So I mentioned that SageMaker is a platform. It's also an integrated development environment. So you might have heard of SageMaker Studio. This is a web-based integrated development environment. It's cloud-based. We have customers that onboard hundreds of data scientists to use SageMaker Studio as their platform for machine learning. We also introduced SageMaker Studio Canvas in the re:Invent conference in 2021. And that's really for business analysts. So there was a great talk yesterday by Anastasia that showed how to build, train, and deploy machine learning models with never writing a single line of code. Right? So if you have business analysts that are interested in, there's also SageMaker Canvas. And there's actually a 4th persona that we're not showing on this screen, and that's really students. Students and machine learning learners, right? People that are coming up to speed on machine learning. Perhaps SageMaker is a lot to handle to get started. Perhaps you don't have an AWS account, and that's where SageMaker Studio Lab comes in. So SageMaker Studio Lab is a free offering, free storage, free compute, no AWS account required. If you have an email address, you can get an account, and it's really intended for students and learners. So there's really a 4th persona up here with SageMaker Studio Labs. Okay, so let's talk about the life cycle of machine learning. This broadly falls into 3 to 4 categories, depending on how we look at it. Here I'm showing it in 3 categories: building, training, and deployment phases. And I'm showing this as part of a circle. This is really a flywheel that we're going to go through multiple times. And you might not see this if we take a class in machine learning. We really focus in our education of machine learning on the data preparation, model training, and model evaluation. There's so much focus on that, and there's very little focus on the deploying pieces to production. How do we let others use the model? So if we start at the build phase, right, I talked to lots of customers. They almost all have data. And we also live in a very unique time that open source data sets are available, right, to get started with machine learning regardless of the problem that you're working on. So the first thing, we might need to collect data. We might need to fetch data. We might need to label data, especially if we want to use supervised machine learning techniques where we need a predictive label. Right? That could be a class. That could be a number if we're going to do a regression-based problem. So we're going to have to collect our data, and that's the first phase there. We're also going to have to clean our data, clean and prepare our data for model training. So what does that mean to clean data? We might have to convert categorical variables into one-hot encoded variables. We might have to deal with missing values. We might have to deal with timestamps or other feature engineering that we might want to do. But ultimately, we're preparing our data sets to train a machine learning model, to train a predictive model. We're also in this phase of build. We're going to be splitting our data sets into train, test, validation. This could be cross-validation techniques. There's a number of techniques that we could use in this phase to prepare our data. Once we have a clean, prepared data set, we're now going to move into the next phase, which is the training phase. This is where we're going to train the machine learning models. We're going to be optimizing the weights. In the case of a neural network, we're going to be using gradient descent to optimize those weights. And we're also going to be evaluating the model after we've trained it. How well does it perform on the holdout data set? This is bread and butter data science, right, that we're going to evaluate. It's also in this phase that we might perform hyperparameter optimization. If that's a new term to you, it means nothing else than just tweaking the knobs of an algorithm to get even more performance out of it. Now, that would occur in the train phase. The last phase here is deployment and monitoring our models. And that's where we're going to spend most of our time today in today's talk, of deploying a model to production and monitoring it once it's in production. And this is an area that's, again, not discussed very often in academic coursework of machine learning. How do we deploy our models? And a lot of data scientists that I talk to, we've trained our models, we've deployed it to production. Others can now use the model. Let's high five, we're done. But in many communities, machine learning communities, the view is just the opposite. Your work has only begun at that stage. And it's very important that we monitor these machine learning models in production. We need to monitor them for drift. This could be model drift, data drift, right? Where the underlying data changes, right? There's no better example of monitoring your models and data drift than the COVID pandemic. You can imagine if we trained a machine learning model for sales prediction on historical data from March 2020 and before. So we trained our model, it worked perfect. We evaluated our model in the holdout data set. We deployed it, it's March 2020. Well, April 2020, that model is no longer valid. The world has changed. The data has changed. And what's really happening is it's the statistical distribution of the data that we trained on is now very different than the statistical distribution of the data that is coming into the model. The real world has changed, and we need to be aware of that. So monitoring our model, and if we can, collecting data, real-world data that's coming into our model, that is gold. That completes the flywheel here, because the new data is how the real world is behaving. If we can relabel that data, we're now going through this cycle again. Now we have version 2 of our model, version 10 of our model, version 100 of our model, and each time we go through the cycle, our model improves, and it reflects the most recent data and the most recent interactions with our model. Again, I mentioned this already, but SageMaker supports this end-to-end life cycle. And you'll hear this term, MLOps, machine learning ops. What is that that's drawn on here? That really comes down to automation and reproducibility. So we can manually go through these steps of building, training, deploying, and monitoring a model. But how do we automate it? So I don't have to call my colleague to say, the model's ready for deployment. We can automate it. We can have reproducibility where we're not only versioning our code, we're versioning our data, we're versioning our configuration files. It's a different way of thinking of DevOps for machine learning than what we might be traditionally used to. Okay, so let's focus now on the deployment side. I want to train a model. Let's suppose here that I have a model that is used for fraud prediction. This is a global online retailer. There's purchases that come in 24 hours a day, 7 days a week. And every purchase, I need to run through a fraud prediction model. Every single purchase. What sort of inference endpoint would I use for that? Well, the first one that we're going to talk about is a real-time inference endpoint. And oh, by the way, I think I might have skipped this, but this term inference, if that's new to you, it's nothing more than machine learning speak for prediction. We're no longer training our machine learning model, we're using it. We're using it. We're letting others use it to get predictions, right? This is really the most important area of the machine learning life cycle, where we finally get to make predictions and find insights in our data. Okay, so back to the global retailer, we have this fraud prediction model. We could use a real-time inference endpoint. What in the heck is a real-time inference endpoint? A real-time endpoint within SageMaker is one that you can deploy that's going to be up 24 hours a day, 7 days a week, does not come offline. This is a low latency endpoint with very high throughput. And this is really great for customers that have 24 hours a day, 7 days a week type usage patterns. Right? We come back to this idea again. For every one of these, we're going to think about cost, use case, and constraints. And the cost on a real-time inference endpoint is the time in which the endpoint is deployed. So if I deploy an endpoint that's real-time and I never use it, I still pay for it. If I deploy an endpoint that's real-time and I use it 100 times a second, I pay just the same. It's the wall time that this endpoint is active. So that's our cost on a real-time inference endpoint. What are the use cases? Again, high throughput, low latency type predictions. And ultimately, we're deploying this model so others can use it, so our applications can use it, right? And we get a RESTful, secure HTTPS endpoint. We're going to show you in just a moment the gory details of how this works under the hood with SageMaker. Now, what are the constraints for a real-time inference endpoint? Well, the latency, the performance of the model has to return a prediction within 60 seconds. If it doesn't return a prediction within 60 seconds, we get an error. And the input, the payload, we call this the payload, it's also the input to the model, has to be less than 6 megabytes. So 2 constraints on our real-time endpoint. And before we go on for real-time inference, let's talk about a couple of terminology pieces. Let's level set there. So again, we're focusing on the inference side. So if we want to have model predictions, we have to have a model. So we have a trained model. This could be a model that you trained with SageMaker. This could be a model that you downloaded from GitHub. This could be a model that you trained on-prem on your laptop. It doesn't matter what type of model it is or where it came from. As long as we can containerize it, we can use SageMaker for inference. So the first thing is a model. Now, once we tie some compute resources to the model, that becomes a production variant. Right, so when we say I have a fraud prediction model and I wanted to support it with an M5 extra large instance type, now we have a production variant. And endpoint configurations, this is sort of hierarchical, where the model becomes a production variant. Multiple production variants become endpoint configuration. Right, so we can have multiple production variants. And then ultimately, when the model is deployed, we have a single endpoint that's fully managed, and we have a RESTful interface to interact with that. And here in this example, we have a single SageMaker endpoint. We're invoking that endpoint with a HTTP post request. And we have 3 production endpoints, production variants that are supporting it. We have production variant 1, it's model 1. It's deployed to an instance that's an M5 2 extra large, a single instance type. And 70% of the traffic goes to this model. So this is a random weighting. 70% of the traffic that comes into this endpoint is going to go to that model. We control these weights, right? So we can have multiple models supported behind the endpoint. Here we have 2 other production variants. We have one that has 2 instances, 20% of the probability of the inference requests go to this variant 2. And then finally, 10% go to variant 3. Right? So this is an example of production variants supporting a single endpoint. And you might think, Aaron, why do I care about production variants? Well, come back to that flywheel. As we go through it one time, we have variant 1. As we go through it again, we have variant 2. Perhaps we're not ready to switch a blue-green deployment to say, we're going to take all of the traffic from Model A and switch it to Model B or version 2. So that's a common architecture where we might slowly introduce the new model using these weighted weights for the SageMaker endpoints. And then we can also change these weights over time. Right, so we can slowly ramp up the new model to where we want to have now 90% of the traffic coming to the new variant. So lots of options there. Let's deep dive on what happens when we do deploy a model with SageMaker, a real-time model. Okay, so with SageMaker, there's a number of ways to interact with the service. We don't have to use SageMaker Studio IDE. That's one option that we have. If we're more comfortable using, let's say, Java or Ruby, we can interact with the APIs that way through the AWS SDKs. Maybe we're more comfortable from the command line. Like we want to use the AWS command line. We can interact with the SageMaker APIs that way as well. We also have a SageMaker Python SDK. And think of this as a high-level library that's really providing convenience functions for training, deploying, and monitoring your models. We can use that as well. So in this example, I'm using that SageMaker Python SDK library. I'm going to deploy a model using this convenience function where I take the trained model estimator and I do a .deploy. And as part of that, I also have to provide my configuration. So here I'm going to say, I'm going to deploy this model to an M5 large instance, and I want 2 of them. So 2 computers supporting this endpoint. What happens under the hood when we do that with SageMaker? So everything in this black box here is the managed service, is the management that I don't have to do. I have to call .deploy. I get a RESTful endpoint out of it, real-time endpoint that's up 24 hours a day, 7 days a week. The first thing that SageMaker is going to do, number 1 here, is it's going to go find 2 of those instances based on my configuration. M5 large instances, it's going to go find those in the region that I'm operating in. SageMaker is smart enough, too, to deploy those in different availability zones. I don't have to tell it to do that. It's going to do that on its own. It's going to start to bring those instances online. It's going to copy over software to them. It's going to copy over the model artifacts. So again, the model artifacts are the trained model artifacts. These could come from SageMaker training jobs. These could come from GitHub repo. These could come from on-prem model training. As long as we have the model artifacts in S3, we're going to copy those over to those 2 new instances that come online. And then also we're going to copy over the inference code, the prediction code. How do we handle and invoke the model? So here we're showing that as a container registry, and we have a number of 17 different built-in algorithms within SageMaker. You can use those built-in algorithms, or you can bring your own. You can bring your own container. So it's going to copy over that inference container as well. It's going to put a load balancer in front of the 2 instances, and then as a user, as a client, I just interact with that endpoint. I don't know that it has 2 instances behind it. I don't know that there's auto-scaling policies. I just get to interact with the endpoint that stays up 24 hours a day, 7 days a week. And before we leave this slide, one of the questions that I get from a lot of customers is, you show this endpoint, Aaron. You show this single endpoint. How do I invoke it? And we could invoke it HTTPS, post request, invoke it directly. That's one option. There's really 2 other popular options, though, that we see. So we'll see customers put API gateway in front of the SageMaker endpoint. Just gives you a little bit more control over how you design that API. Additionally, if you wanted a single API to do multiple functions, you could do that as well with API gateway. The other common pattern that I see is API gateway with a serverless Lambda function that then invokes the SageMaker endpoint. You might think, well, why? Now you're introducing more services. Why are we doing this? Well, perhaps we want to do a little bit of pre-processing in that Lambda function before we invoke it. So that's another common pattern that you might see before the inference request. You have options there. So it doesn't have to be one size fits all. Okay, before we leave real-time inference, there's a couple more important points. And I already talked about deployment. So this is the endpoint configuration, where we have a new model that comes online and we want to swap it out. We can do blue-green deployments, and we can adjust those production variant weights, where a certain probability of inference requests go to model A, B, or C. Everything we've talked about so far, though, is a single real-time endpoint that's being deployed. Well, what if I have a model, let's use this fraud example again. Maybe I have a trained model based on behavior of our customers, and I have a model for every single state, right? I have a Kentucky model, I have a Missouri model, I have a New York model. Now, I could go and take those trained models and deploy them to 50 different real-time endpoints. Right? I could do that. That's going to cost me 50 times what I'm paying for a single real-time endpoint. Perhaps the better pattern would be to deploy multiple models behind the single endpoint. We also support what's known as multi-model endpoints. So now we can host multiple models behind a single real-time endpoint, and now as part of the request, now I'm not just giving the request the input parameters that the model expects. I'm also, whoops, go back here. I'm also specifying as part of the code to invoke it, what is the model that I want? Give me the Kentucky model. Give me the Missouri model. And as part of the inference request, I specify that. SageMaker's managed, so it handles it behind the scenes. It automatically pulls those models, caches them, dynamically caching them, handling loading new models that haven't been used frequently, and removing models that haven't been used frequently from that cache. Right? So lots of power, lots of cost savings in the multi-model endpoint. So if you're using real-time endpoints, you're going to want to think about multi-model endpoints as an option for cost savings. Okay, so I talked about the constraints earlier, right? 6 megabytes on the payload, 60 seconds. Well, what if I have payloads that are larger than that? Maybe I have a geospatial analysis for object detection. We're going to take satellite imagery, and we're going to train a model for detecting ships in the satellite images. Typically, satellite images are much larger than 6 megabytes, right? So now I'm stuck. I can't use this real-time endpoint. Well, we just introduced last year, this was about August of 2021, asynchronous inference. So asynchronous inference is very similar to a real-time endpoint, but now the queuing of the model is handled by SageMaker. And now we're not bound by the constraints that the real-time endpoint had. We're not bound by the 60-second timeout. Now we can handle timeouts that are up to 15 minutes. And we can also handle payload sizes up to 1 gig. All right, so it changes the game on the models that we support. And what is the use case for something like this? Again, very large payloads, very long processing time. You could also imagine a model that's going to do transformer-based text analysis, and if you're going to process a whole document in a single inference, that might take longer than 60 seconds. So there you would use an asynchronous endpoint. And there's one other awesome thing about asynchronous endpoints, and it's auto-scaling. We haven't talked in depth about auto-scaling yet, but for each of these endpoints, we can control on how it scales up and scales down to meet the demand of our customers. Right? So as they use it, we need the endpoint to auto-scale. Asynchronous endpoints allow us one very cool option, is we can scale this endpoint down to 0 now. So back to that cost equation, if I'm not using it, I'm not paying for it, which is the great thing about asynchronous endpoints. That doesn't exist for the real-time endpoint because our constraints there were up 24 hours a day, 7 days a week. We can't scale that down to 0. So if you have the option to use an asynchronous endpoint, I would configure auto-scaling down to 0, but we have to be able to tolerate those longer latency periods where we haven't used the model for a while and we have to bring it back online. So you'll see a bit longer latency there. Okay, so we've talked about real-time endpoints. We've talked about asynchronous endpoints. You know, a geospatial example with these very large payloads would be a good example, or long processing time. What if I need a machine learning model to provide predictions, but I don't need it up 24 hours a day, 7 days a week? And the example I always think about is one that I've used before in real life. I had to produce a report for management, and I needed to do this once a month. And as part of that report, I had to create some visualizations. Part of those visualizations came from a machine learning model. Do I want to pay for a real-time endpoint to be up 24 hours a day, 7 days a week for a month, and I'm going to use it once? I'm going to use it once. On the weekend, I'm going to pay for it. During the week, I'm going to pay for it. No. I want to pay for it just the period of time that I'm going to use it. And that's where batch transforms. This is yet another option for inference within SageMaker. Batch transform is different than real time. It comes online and it processes the input data, runs that through the trained model, saves the model, or save those predictions back to S3, and then tears down the compute. Again, it's very similar to a real-time endpoint. We have to specify compute as part of this, but we only pay for the time that we process the data. We only pay for the time that that compute was alive. This also can be a good use case if you have very large data sets. All right, so maybe you have a terabyte of data that you need to process through your trained model. You could use a batch transform to do that, and you don't need that persistent endpoint. One other way I like to think about it is we have the inputs already, and we want to process those through the trained model, right? And many times in a real-time endpoint, we don't have those inputs. We're waiting for a customer to make a purchase so we can run it through the fraud prediction model. A batch transform is when we have a priori all of the inputs. Okay, and let's show in detail, just like we did with the real-time endpoint, because SageMaker is a managed service, how is this different than the real-time endpoint, the batch endpoint? Again, we have the same options here for invoking, right? So we could use whatever we're comfortable with, command line interface, a number of different AWS SDKs with popular languages. And I always recommend to customers, like, use what you're used to, right? Don't learn the SageMaker SDK if you're already used to using the AWS CLI. Use what you're used to. Use what allows you to move fast enough. Okay, so for batch transform, recall that last time we used the SageMaker Python SDK, and I called a .deploy to create that real-time endpoint. Now I'm going to call a .transform. This is the difference between a real-time endpoint and a batch transform. Still, I have to configure that with an M5 large instance, and I'm going to use 2 of those. Again, this is options that you control. And we'll talk about how to determine that a little bit later. What is the instance type? An M5 large is kind of general purpose compute, and we're going to use 2 of those. So what happens under the hood when we do that? Everything, again, in the black box is the managed service. All I have to do is call the .transform on this. First thing, SageMaker is going to go find those M5 instances. It's going to spin them up. It's going to put them in different availability zones again, just as we saw with the real-time endpoint. But now, instead of copying just the model artifacts from the S3 bucket, it's also going to copy over the data that we want to process. Right? We want to process a lot of data. That data needs to live in S3 to start. So we have the model and the model artifacts going to these instances. We still need the inference code or the inference container. We're going to process that data through the endpoint, and then we're going to save the inference. We're going to save the predictions that came out of the trained model, and we're going to save those to S3. So now the data that we use for predictions and the predictions, the input and the output of the model, are both living in S3. We also get to control where those live. Those could be the same bucket. Those could be different buckets. We get to control that as part of our configuration. So a little bit different than the real-time endpoint. We don't have that load balancer. We don't have the RESTful interface, but we can still process large amounts of data out through that inference output. Okay, so serverless endpoints. Everything we've talked about so far, batch transform, real-time endpoints, asynchronous endpoints. We had to specify the compute. We had to specify that we want an M5 extra large or a GPU or a memory optimized unit. Maybe I don't know, or maybe I don't care what is the underlying compute. And that's where serverless inference comes in. So serverless inference was announced at reInvent 2021. And it's really the use case, back to these terminology for each endpoint, cost, use case, and constraints. The use case for a serverless endpoint is not steady state traffic, but spiky traffic, right? So maybe we work on a food delivery app, and as part of that food delivery app, we provide personalization recommendations, right? We're using a machine learning model to do that. So we see very spiky workloads, right? Lunchtime, we see a ton of requests. Dinner time, we see a lot of requests, but during the middle of the night, we don't see hardly any recommendations for food to eat. And that would be a perfect use case for serverless endpoints. How do we use serverless endpoints? Well, first of all, we have to have a container that's going to include our inference code. Just the same like we're going to have a container when we use the real-time endpoint and we pulled it from the container registry. Again, this could be a model that we trained with SageMaker. This could be a model that we downloaded from GitHub. This could be a model that we trained on-prem. Doesn't matter where it came from. We need the model artifacts, right? So that's the S3 location. It's looking very familiar to the real-time endpoint that we. And we also have to choose a memory size. So now instead of saying what is the compute, like an M5 large or a GPU, now we have to choose a memory size. And this is really what is the RAM that's going to support this serverless function. And we have options now between 1 gig all the way up to 6 gigs on memory size to use for your serverless endpoint. That's all we need. The auto-scaling automatically happens. The cost is now very different. So when we talked about real-time endpoints, the cost that we paid for the inference was as long as the inference was active. As long as that instance was active, we were paying for it. Now with serverless, we just pay for what we use, right? If we use it a lot during lunchtime, we pay for that usage, down to the millisecond. Just if you're familiar with Lambda functions, it's very similar. We pay for that underlying compute that we use and nothing more. We get logging through CloudWatch, and we still get to send our inference request to the serverless endpoints just like we're used to. The end user doesn't know that it's operating with a serverless inference versus a real-time inference. Again, this is great for spiky workloads that aren't steady state. A couple of constraints. So we talked about the cost. You pay for what you use. The use case is spiky workloads. Let's talk about constraints for the serverless endpoints. Right now, we don't support GPUs for serverless inference. Right, so that would be a constraint. If you had to have a GPU to process your data for the prediction or the inference phase, that might be a constraint where you wouldn't use the serverless endpoint. Okay, so we talked at length about real-time endpoints, batch transform endpoints, asynchronous endpoints where our payloads are larger and our latency is larger. We've talked about all those 4 different options that we have. We get to select those. What are the best practices on how to get started? And I like to think about this as really optimization, right? For 3 of the options, we had to specify the underlying compute. We had to specify the instance type. And with SageMaker, we have over 70 different instances that you can use. To me, as a user, that's mind-blowing. How do I pick out of these 70, right? M5, I got GPUs, I got memory optimized, I get network optimized. And the last thing that I want to do as a user of SageMaker is to leave compute on the table and not use it all. Right? So we want to maximize the utilization of the compute that we use. That's the first tip that we have. And you might say, well, like, how am I going to pick this? And a bunch of trial and error. Well, we now have Inference Recommender. It's a new offering where you provide the model, you tell it what type of model it is. This is a computer vision model for object detection, and we want latency below X. We allow Inference Recommender to load test that model, and it provides us recommendation not only for the endpoint configuration, the instance type, how many instances. it gives us all that information. So we can use that to help select the instance that we want to use. Or if we don't want to select it all, let's use those serverless endpoints where we just specify the memory. If we're using real-time endpoints, don't forget to delete your endpoints that you aren't using because you are charged as they are active, right? So if it's a Friday and you're testing, don't forget to delete that endpoint before you're done for the day. And if you're able to host multiple models under a single endpoint, that's again another cost reduction that you can do. And then the last thing on this slide for cost optimization is we have another service called SageMaker Neo. And SageMaker Neo is really for optimizing our trained machine learning models. A lot of times customers will use this for edge-based deployments. I want to deploy my model to an NVIDIA Jetson. I want to deploy my model to a Raspberry Pi. But maybe my model's too big. I can use SageMaker Neo to compress that model, to optimize the model. But it doesn't have to be just for edge devices. Right? I can also use it for cloud-based deployments. Maybe I want to improve the latency of the model. I could reduce it with SageMaker Neo. Right? So that's another option that we have as well to compress the model size, improve the performance. And then the last thing is SageMaker usage plan. So if you know that you're going to have workloads over, committed workloads over 1 year to 3 years, we have SageMaker usage plans, savings plans, and this can provide up to 60% savings within Amazon SageMaker usage. This is good for training, this is for building, processing jobs, training jobs, and deployment jobs. Okay, so we've talked about a lot, and I want to think about how would I get started. Not necessarily how would I get started with machine learning, we'll talk about that in just a moment, but how do I get started with picking what style is right for me, right? That's what we came here to talk about, inference. What style is right for me? And I always come back to the use case. How's your customers going to interact with the model? Is this a spiky workload? Is this an intermittent workload? Is this a real-time use case? And also requirements. Right? What's the latency requirement for your model? And I talk to customers all the time, and they say, Aaron, I have no idea what the latency is for my model. I have no idea what the requirement for the latency is. My recommendation is to pick something and to write it down. These requirements are not static, right? We're going to revisit them and say, actually, our latency was not 1 second. It was actually 100 milliseconds. And actually, it wasn't 100 milliseconds. It was 90 milliseconds. We're going to refine these requirements over time, but pick something and write it down. So that's important for defining requirements. And then the last thing, and one of the most important things that we'll talk today, comes back to that flywheel, where we close the loop on deploying a model and monitoring it, and we're going to go through that again for version 2. Before we start deploying machine learning models to production, we've got to think about our strategy for closing that loop of the flywheel. What is our strategy? And this comes back to the machine learning ops topic as well, for retraining our model and redeploying it. So suppose the pandemic does happen, right? And we have data drift, and we need to retrain our model. That can't be a manual process that we're thinking about only when it comes time to retrain the model. We need to think about that ahead of time and have a strategy and a plan for not only alerting the engineering team, but also retraining and redeploying that model. So think about that before you put it in production. So we dove deep on SageMaker inference, again, the prediction phase of machine learning. There might be some in the crowd that say, I'm not even there yet. I'm still coming up to speed on machine learning. And how do I get started with that? Well, there's a number of ways to get started. It's really, we're drowning in content for machine learning on how to get started. We have Skill Builders, which is over 500 free courses, right? You can take a look at that QR code. We also have certifications that we support, and this could be the SA Associate. We have specialty certifications for machine learning. One thing that's not listed on here that I would recommend as well is Machine Learning University. So this is a new offering from AWS. It's free on YouTube. So if you're interested in getting up to speed on data science and machine learning, there's courses on tabular data problems, natural language processing, computer vision, and it's based on the same courses that we teach internally to our engineers and solutions architect within AWS. So Machine Learning University on YouTube. So with that, I want to thank you for your time today. Again, I'm Aaron Sunstacken, and you can always get a hold of me at awsaaron@amazon.com. Feel free to reach out anytime. I might not be able to answer your question, but I can find the right person to help. So I want to thank you, and then most importantly, if you could please take the survey from this. We want to hear from you. If you like this talk, we want to hear about that. If you hated this talk, we want to hear about that as well. So this is the only way that we can get better. So I will hang out for about 10 minutes and answer any questions that the crowd might have, and then I'll also be out in the hallway if anybody wants to talk afterwards as well. So again, thank you very much. Any questions? There's one back here.
Hi. For the batch transform, you mentioned that the data has to be in the S3. So what if your production data is in, say, Redshift? You know, how do you use that data for your batch transform?
Yeah, so his question was, for batch transform, I mentioned that the data has to be in S3. We're going to process a bunch of data. What if your data was in Redshift? We actually have other options for using your model within Redshift, where we could call the model from a Redshift function. So batch transform for that example might not be appropriate, and there might be other options that you might pursue. But yeah, to use a batch transform endpoint where we're going to bring it online with the trained model artifacts, that would be, we need our data to be in S3.
So when you want to dump, is there a way to like dump the data out of Redshift into S3, or would you use something else?
You could take a snapshot of the data from Redshift and process it, absolutely. There's a number of different intermediate options that you could do to process large amounts of data through the endpoint. But it also, like I mentioned, there's ways to interact with the trained model from Redshift as well. Redshift ML is what I would recommend you take a look at. Other questions?
Yes, I have many questions in one. So I want to find out basic, how extensive this application can be. Meaning, I'll give you a couple examples. Let's say you want to monitor all sorts of data, and you said the data has to be in S3. Can it go outside and collect all other types of data, satellite communication from all different directions, let's say weather patterns, weather temperature, water temperature, anything like that, right? To predict and do multiple predicting on food chain, food growth, fish movements, depending on these predictions. Another one can be IT security, right? Going to the logs of multiple devices, collect the data, do predictions on what's being hit, when it's being hit from different companies, read multiple emails, who's clicking on phishing and things like that, to do a prediction on which companies, what the time they're going to be, you know, their data is going to be accessed or hacked or things like that.
Yeah.
Create a software on that. So, and if it doesn't handle all that, who do we talk, and what's the AWS or Amazon contacts to create something or collaborate with Amazon?
Yeah, so his question was about models that incorporate data from all different sources. This could be a satellite imagery problem, a cybersecurity problem. My comment earlier about your data needs to live in S3 only applies to the batch transform, right? So if you have a trained model that you've developed for cybersecurity, and you deploy that to a real-time endpoint, your data never needs to be in S3 in the inference phase. You're going to interact with that data through the RESTful API, or the RESTful interface of the real-time endpoint. Your question, though, was also about how do we train a model like that? SageMaker is a platform that would allow you to train a model like that, but it won't do it for you. So it's a managed service in the sense that it's going to manage the underlying compute, but it's not going to train and go collect data for you. That's still the job of the data scientist, to go collect that data, select the right algorithm to use, train that model, evaluate that model. This is merely a platform and a tool set that will help you do that more efficiently. Right, so these are not fully pre-trained models. And if you're interested in that type of pre-trained models, maybe for computer vision or NLP, I'd recommend that you take a look at what are termed the AI services. So that's going to be Amazon Recognition, Amazon Comprehend, Amazon Transcribe, Amazon Forecast. There's a number of these different pre-trained models that you can interact with.
So will this work with all these other tools in there? There is many tools where you can get the data and create you prediction models and software, and you can deploy the software into a machine based on the prediction, and it will read the inputs that you have trained, and it'll give you an outcome, for example.
Yep, absolutely. So again, this is a platform that you can use for your trained models to help deploy them. It will not do that for you, though. You still have to build the models yourself. So thanks for the question.
Is there anybody, I mean, I can get your contacts later on, but is there anybody else that we can, like, hey, this company wants to develop this further or wants to add some more features to this?
Yeah, so we have a number of partners that you might be able to work with, AWS partners or AWS professional services if you want them to do it end-to-end for you. But again, this platform of SageMaker is a managed platform, but it still allows you as a data scientist to approach any problem type. Tabular problems, computer vision problems, natural language forecasting problems, clustering problems. It doesn't matter the problem type. It's the platform for data science on AWS. We can talk after in the hallway if you have some follow-ups. Next question. There's one up front.
Thank you. So if your model needs to use GPU for the inference, like what would be the most cost-efficient method to do that?
Yeah, so his question was if your model needs to use a GPU for inference, what would be the most cost-effective? Well, we know serverless is out, right, because we don't support GPUs. Then I would come back to use cases, right? Do you have the data that you already, the input data to the model? If you do and you just need to process it through the trained model, then I would use batch transforms. I can select a GPU instance type. So in the example I showed M5 instance, that's a CPU-based instance. It doesn't include a GPU. But we can use a number of other instance types that have GPUs, have a cluster of GPUs for inference. We could use that with batch transform, asynchronous inference, or real-time inference. From a cost perspective, I would suggest that you look at either batch transform or asynchronous inference because that real-time endpoint is going to stay up and you pay for it when it's up. So I would start there and then progress down.
And for the asynchronous and the batch transform, is it the cost is pay as you use or?
Asynchronous and batch transform, the cost is how long it takes to process the data. So asynchronous, if we don't have auto-scaling down to 0, we pay for it just like a real-time endpoint. If we have auto-scaling down to 0, as soon as it goes down to 0, we don't pay for anything. So we only pay when that endpoint is active. For batch transform, we pay for the amount of time that the instance is active to process the data through.
Thank you.
Mm-hmm. There's a question back here.
So I was curious if there's any SageMaker-related offerings for monitoring specifically, like, for instance, model drift. You can imagine you have your inputs and you know what you're expecting to get out, and can you model how, or monitor at least, how that's going to alert you when you need to change something?
Yeah, so his question, are there any SageMaker tools that we can use to help monitor the models that are in production? We focused on deploying models to production here, but how do we monitor them? Yes, absolutely. SageMaker Model Monitor. So Model Monitor is a processing job that runs on a cron-based schedule. Right? So you can say, I want to monitor for drift every hour, every day, every week, every 36 hours, where we're going to take a look at the baseline statistics, the statistical distribution of that input data that we train the model on, and we're going to compare that to the data that's coming into the model. Is it different? We get to control when we get alerted, right? So it's not just data and concept drift. We could also look for post-training bias. We could also look for schema changes. So maybe I trained a model, and I'm expecting an RGB image to come in, and now I see black and white images, right? So now the tensor of the model that's going, or the image that's coming in, now only has a single channel. It's grayscale image, right? We could alert on that because now the schema has changed. The constraints have changed. We can also alert on completeness of the data. Maybe we get an inference request that's missing 50% of the parameters, and we want to alert on that. We can control those alerts, and we use CloudWatch for our alerting function within model monitoring. So we can alert the engineering team automatically, but expect if you're using Model Monitor, so I gave a reInvent talk about model monitoring, that you're going to have to adjust these thresholds, right? This is not a set it and forget it, we high five, we go home. Because the last thing that we want to have happen is like we set it and forget it, and the whole engineering team gets used to the alarm going off. We ignore it. Well, why do we monitor it in the first place, right? We don't want the alert fatigue to take place. So expect to revisit that. And you know, if I was managing an engineering team that were monitoring models in production, this would be something that we'd look at weekly, right? What are the limits? What are the alerts that we're seeing? Do we need to change those or update them? So good question. Any other questions? All right, if there are no more questions, thank you again. Again, I'm Aaron Sinstacken. I'll be out in the hallway if you want to talk, but thanks for coming. Thanks for coming to the DC Summit.
Thank you.